recall just now. So sometime when it comes to fractions, you may get asked to solve an equation or solve equations where you're going to see fractions in them. Okay. There'll be plenty without the fractions, but every now and again you see one with fractions. So we need to be able to work with those fractions. And the thing we do when we get fraction, we try to eliminate the fraction. We try to get rid of that term at the bottom by always trying to keep the same ratio. Okay. So in order to do that, we apply this method called we multiply. So in order to get rid of the 4, because I've got to divide by 4, what's the opposite of dividing? Multiplying. And that's why we multiply by 4. To get rid of the divide by 4, we're going to multiply by 4. But what we need to do is we need to keep what we call a balance. So if we multiply this fraction by 4, we need to multiply this term as well by 4. That means the whole side here has been multiplied by 4. But because an equation is just a balance, what we do on the left, we need to do the same on the right. So then we need to do 4 times 8 as well. Okay.
Right, okay.
So every term is going to be multiplied by 4 here. So the first term is this fraction. So if I time 4, the whole x plus 2 divided by 4, the 4 and the 4 will cancel each other. And then 4 times 5 will become 20. Okay. And on the other side, I'll have equal 4 times 8. So let's see how it works. Time 4, x plus 2 plus 20 equals 32. So if you were to see it, it's a bit like I went from 4 times x plus 2. Did you see that I'm opening the brackets?
Yeah.
Divided by 4. So that's the first thing I've done. I've timed 4 times 5, which become 20. And on the other side, I've just timed 4 by 8. 4 times 8 is 32.
Yep.
Remember when we were simplifying 4 and 4? Becomes a 1. 1 divided by 1 is just 1. And that's how you end up with x plus 2 plus 20 equals 32. So that fraction is just x plus 2 divided by 1, which is just anything divided by 1 is that thing that you've got. X plus 2 plus 20 equals 32. Now we're going to group the like. So I've got 20 and 2. That becomes 22. And the 32 is still the 32 there. Now you've been asked to solve this equation. How do we solve an equation? We use again the balancing method. The balancing method is trying to get you to have x on its own here. To get x on its own, because I'm adding 22, I need to do the opposite of adding 22. So what's the opposite of adding?
Subtract.
Subtract 22. So I subtract 22 on this side, and the balancing method tells me that whatever I do on the left, I need to do the same on the right. Yeah? So if I subtract those two, they're gone. I end up with my x. What's 32 take away 22?
Sorry, 10.
Yeah.
10.
Yeah. X equals 10.
Could you not just work that out the step before? Like, I know obviously that's a simple one to start you off with,
Yeah.
but...
Yeah, you could have said, oh, I can see that x equals 10.
Jump straight to x.
Yeah. I'm just giving you the technique. So if one day you get x plus 3 over 2, you don't get, oh, I don't know what fraction I need to add to another fraction. You just say,
Right,
I'm going to take away 3 over 2 on each side.
Yeah.
Yeah. Like you said, it's on a simple one that you learn the technique first. And then once you've got it, it becomes a habit. It's more the way, yeah, but you're right. in some school I've seen where they say, oh, what, yeah, primary, you'll go, what do you need to add to 22 to get 32? And they all go, yeah, add 10. And that's why
Yeah.
X is 10. But when it comes to manipulating surds and stuff like that, if you ask, what do you need to add to root 7? Then they'll go, yeah.
Sure,
Okay.
sure, of course.
So this is a technique that is applied quite often whenever you're going to work with fractions or solving an equations that include a fraction. So that was an easy fraction. Now have a look what they've done on the second one. They've put two fractions, but not only they've put two fractions, but they've added brackets in them, and you go, why have they done this? But anyway, we need to get rid of those denominator. Okay, so two ways of doing this, actually. There's not just one way. We can try and say, I know that my common denominator here is 3 times 2.
Mm-hmm.
Yeah, so if I was to time by 6, both, that would get rid of that 2 and that would get rid of the 3. Remember the cross and smile was telling me this is 2 times 3. Yeah, so by timing by 6, now this time I get 6 times 3 divided by 2, but 6 divided by 2 is 3. Then that's why you get 3 times 3 is 9 times 2x minus 4. 6 times 2x divided by 3 is 12x divided by 3 is 4x. And 6 times 16 becomes your 96. Yeah?
Yep.
So,
6.
so basically we found a common denominator, which is 6, and I've decided to multiply that whole side, or this fraction, then this fraction by 6. So maybe it's probably safer if we write it on the side, so at least you know what we're doing. So it's 6 times 3 times 2x minus 4. That's
6 times
basic.
3 is 18. Or am I just talking nonsense?
Yeah, 6 times 3 is 18. And then we divide by 2.
Ah, right, okay. And then you're dividing by the 2. Right,
That's
okay,
why
so
you get the 9. Remember, we're trying to get rid of those fractions, because now that we've got this, it becomes much easier. And on the other side, we said 6 times 2 x divided by 3. And try and get to the habit of, when you write an x, you write it with curly x, and when you write a multiply, it's just cross. Yeah?
Yep.
12 divided by 3 is 4. 18 divided by 2 is 9. But you still get the 2x minus 4. And here, 2 times 2x is 4x. And the bit that a lot of time we forget to do is the 6 times 16.
6.
So that shows you all the work in there. So next stage, we get rid of the brackets. Expand, remember, we're not here to factorize. We're trying to find x on its own. So 9 times 2x, that'll be 18x. 9 times negative 4, that's negative 36. Plus 4x equal 96. Yeah? 18x minus 36 plus 4x equal 96. Now we do a bit of tidying up. 18x plus 4x. How many x's?
22x.
22x. Minus 36 equal 96. See, now that the numbers are getting a bit bigger, it's going to be harder for you to find x by trying to figure out what it is. So you're going to add 36 on each side, yeah, to get rid of the takeaway 36. 96 plus 36 is 102 plus 30, 136. Then 22x equal 136. Sorry, 132. 6 plus 6 is 12. 132. Now, two things here. If it's a non-calculator one, okay,
Mhm.
I'm going to give you a quick tip. 22 is 2 times what?
11.
11.
11. Okay. Whenever you're going to see 3-digit numbers, right? 1, 3, and 2. If you add the 2-digit on both sides, 1 and 2, if the sum of those two is equal to the number in the middle, that is a multiple of 11. Yeah. So if you
Yep.
if you're not too sure, just try 451. 4 and 1 makes 5. Use your calculator, divide that by 11, and tell me if you don't get a number without any remainder. So 451 divided by 11 is 41. Now try 154 divided by 11, just to convince yourself, and this should be
14.
a multiple of 11. So whenever I see this, 132, I know straight away I've got a multiple of 11. 22 is 2 times 11. So hopefully I should end up with 2x equals something of the 11 basically should come out of this. Yeah?
Mhm.
Yep.
So next stage, divide by 22 both sides, and you'll get your 6. But what I was telling you here is, if you don't have a calculator, the other thing you could do is you can say to yourself, 22 is 2 times 11, 132 is 2 times, so 100 is 50, 65, 66, sorry, 120 is 60, plus 6, 66, yeah?
Yes.
2 times 66. And now you should be seeing the 11 a bit better. Yeah? Because
Yeah.
it's 11
Mm.
times 6. So on one
Mhm.
side, you've got 2 times 11. And on the other side, you've got 2 times 11 times 6. This isn't just me giving you a quick tip on if you don't have a calculator, if you've got a non-calculator question, how you deal with that. And because you divide by 2 times 11, you end up with just a 6.
Right. Okay.
Yeah.
Yeah. Otherwise, you just use your calculator and just do 132 divided by 22, and that's 6. Yeah. Because
Yep.
I don't think in schools they teach
No, I've never
the
heard of
children how
Or
to
just
do
like that.
the long divisions. In the old days, we used to have to do it, but you guys are too young to see that this has been taught in schools. So that's why you need to have ways to manipulate the numbers to make it easier for you.
that. Yeah.
The only way is to break that down by knowing it's a multiple of 2, but you know it's a multiple of 11, the 22. But 132, you might have not noticed it, but if you break it by 2 times 66, then you can see it now. It's 2 times 11 times 6. Okay. So let's work together with these guys. I've put it there. I'm going to get you out of your misery and not giving to you all of it as a homework, because some of them come in are tedious and it's step by step, and I just don't want you to try them and go, this is too hard. So they're in page 50,
Question 1.
6b, question 1. Is that 6b?
Yep.
Yeah. So let's work our way, because I know they look a bit complicated, but we're going to tackle them one at a time. So whenever I see this, remember what I said? I need to get rid of that x. When we had numbers, to get rid of the number, we time it by the number. So to get rid of this x, I need to time by x. So that's going to be my first step. I need to time the numerator by x, and I need to time the denominator. Sorry, yeah, I need to time that whole part by x and time the bottom part by x to keep the same ratio. So if I do x time x plus 1 over x, I'm going to get rid of that fraction there. But again, to keep the ratio, whatever we do at the top, we need to do the same at the bottom, x times x, yeah, at the bottom. First step, x times x,
X squared.
x squared,
Plus 1 over
x times 1 over x is x divided by x. What's x divided by x?
X.
X.
So if I do 7 divided by 7,
There's one.
1. X.
x divided by
And
x,
X over X, is that not one as well then?
yeah, no matter what value you put in x, it's always going to be 1. Because I can put 10 for x, I'm always getting 1. So x divided by x is just 1. And that's how we get rid of that x, by just timing the top by x. So x squared plus 1 divided by x squared. Yeah?
Mhm.
So the question is, simplify as far as possible, writing your answers without fractions. So what did we learn with indices? When you've got an index that is negative, it's a bit like making it as a fraction. So x, whatever over x squared just becomes x to the power negative 2. So that's how you get rid of this fraction, time x squared plus 1. So that's how we've just rewritten this difficult fraction into something without a fraction. So this is x squared plus 1, x to the power minus 2. And this is how you would get your last mark here. You got 1 mark for this, and then last mark to write it like this.
You've just taken the you've just taken the denominator and just sort of taken that as the lead and just.
Yeah, this x squared, I just changed it to an x with a negative
Okay.
index, basically.
In order to write it without being a
Without
fraction.
a fraction, yeah.
Yeah.
So whenever you're going to see write without a fraction and you still got a fraction, whatever you've got under there, you just change the sign of the index, and that moves it up. And that was a rule that we learned. Remember when we had 1 over a to the power of n, we just said that the rule is just this is a to the power negative n. We just use that rule. I know we've learned it a while back, but you could see when you would use it, for example. Okay.
Yep.
So x squared plus 1 divided by x squared. Or you can rewrite it. So if they didn't say write it without fractions, I would just stop here. No point you doing this. You're not going to get an extra mark for answering a question not asked. They don't ask you. The second one, here I had x and I timed by x. This time, what do I have for my fraction?
4.
So to get rid of 4, sorry, to get rid of a divide by 4, I need to time by 4. Maybe that's what I should have said here. To get rid of a divide by x, I need to time by x. You do the opposite, basically. So this becomes 4 times 3x plus a quarter.
Over
Remember, we opened the bracket, so we need to close that bracket. Over,
quarter.
A quarter.
keep the ratio. What you do at the top, you need to do the same at the bottom.
So it's 4 times a quarter.
Yeah. So
Then
whatever
you
we.
can
So
take
what's 4 quarter?
It's a half.
4 times a quarter. 1.
Yeah.
1. That's 1.
It's a whole,
Yeah.
yeah. Think about the pizza again. I've got 4 quarter of a pizza. It's a whole because it's just 4 times 1, which is 4 divided by 4. And 4 divided by 4 is just a 1.
Divide by the top and divide by the bottom. Is that what the usual rule is? I don't know. I'm just thinking out loud there.
Or time the top.
Oh, and then
Because
divide by the bottom. Whatever you get from doing that, and then you divide by the bottom, if that makes sense. So times 4 times 1, and then divide 4 by 4, which is 1.
yeah, so 4 times 1 is 4.
Then divide 4 by
Then
4.
because you've got 4 over 4, it becomes 1, yeah.
Yeah. Right, okay.
Whereas at the top, I've got 4 times 3x, that's 12x. Nothing fancy there. And I've got 4 again time a quarter, which is just 1. Four times a quarter is 4 quarters or a whole.
Mm-hmm.
If you want, we can write it with a 4 divided by 4 if you think that's going to be clearer for you.
No, I think it's easier just having it as a 1.
And then at the bottom as well, we've got 4 over 4. Because 4 times. And now you can see that it's 12 plus 1. I just skip a step. 12x plus 1. That's it. Divide by 1 is just 12x plus 1. Anything divided by 1 is just that, anything. Anything divided by itself is 1. So these are the things that we need to work on for fractions. Okay. So now try yourself C. Let me know how you got on. So we did one with an X, one with a number. This time you've got an X, and the next one you've got number. Okay, so we're recording again. So how did we get on with the first one?
I got 4x over 4 is my final answer.
Okay, so if I just copy what's been done on A, I would use X first, yeah?
Yep.
But X times 3X, that's not 4X as far as I know.
I used I used 2 for some reason. I don't know. I must have started off with the wrong number.
And then at the bottom, I've got X times 2, which is just 2X. Yeah? So X times 3X is the same as 3 times X times X. What's 3 times x times x? 3
That's the x squared.
x squared, yeah. Then I've got x times negative 1 over x. It's the same as minus x over x. And we just said minus x over x is just minus 1 divided by 2x. So I'm not too sure. Where
I
do you
used
think?
two for some reason as the kind of, I factored that in and used 2 to multiply by the top and by the bottom
Okay.
for some reason. I don't know why, but is it just you're using, you use, it's not the most common number. I mean, how do you pull out x again? Is that just, am I missing?
So because I want to get rid of that fraction, the only way to get rid of this fraction is to time. This fraction is something divided by x. I need to time by x. The
Okay.
same way we did it here.
Okay.
And
Right.
that's got rid of that fraction to start with. Okay. So here, if we were to simplify this further, we can say this is 3x squared divided by 2x minus 1 divided by 2x, because we've got the same denominator here. It's the same as 3x squared minus 1, the whole thing divided by 2x. Yeah? So this we're just going to leave it. 3x squared divided by 2x is 3 over 2 x nothing I can do really, minus 1 over 2x minus 1 over 2. I still get fractions, but if they tell me you need to get rid of the fraction on x, this is just x to the power minus 1. Remember they said, write your answer without fractions. It's a bit like writing 1.5x minus 0.5x to the power negative 1. If I was being pedantic, I would rather keep 3 over 2 and 1 over 2. Okay, so they're just trying to get you to simplify a fraction. To be honest, leaving it as 3x squared minus 1 divided by 2x is probably just as enough if you were to use that in an application. Okay, so to me, leaving it like this is enough. Leaving it like this is enough. X squared plus 1 divided by x squared, that's enough as well, unless you want to write it as 1 plus 1 over x squared. That's another way of writing this. Yeah, because it's x squared divided by x squared, which is 1, plus 1 divided by x squared. But to me, that's enough here.
Yeah.
The next one here, you will need to time by 3 to get rid of that 3 in the fraction. At the bottom, you will need to time by 2 to get rid of that 2. So if we time by 3 and we time by 2, that's timing by 6. Same here. If you time by 3 and time by 2, you're going to have to time by 6.
6.
So that's why you need to use the 6 this time, or 2 times 3. Yeah?
Yep.
So 2 times 3, which is 6, times x plus a third, divided by 2 times 3 again, 6 times 2x minus a half. again, we need to close the bracket. So what I've done is I've timed by 3, both top and bottom. That got rid of the 3 at the top, but I need to time by 2 again to get rid of the fraction inside the denominator. So that gives me 6x. What's 6 divided by 3?
2.
2, yeah. So 6x plus 2 at the top. So you notice that we got rid of the fraction there. Oh, that's probably what they mean by without fractions. Without fractions either on the denominator or the numerator. I'm understanding the question asked. I don't think it's that clear. 6 times 2x is 12x. 6 times negative 1 over 2 is just negative 6 over 2, which is negative 3.
Yeah, 3.
Yeah.
Success.
And that's us, really. You could try and say, oh, I can time that by 3. Oh, sorry, this is 2.
You know, simplify that down a bit.
3x plus
The
1.
6.
Yeah, so you get the 3x plus 1 if you want there.
It's 1, yeah.
But the problem is, it's not going to simplify with the bottom, because the bottom you've got a 3
4, yeah, 3.
times 4x
Minus 1.
Yeah.
minus 1. So we've not simplified it further. We've just factorized it.
Still a
All
fraction.
right.
But they didn't ask us to factorize. We've just, yeah. It says simplify it as far as possible. It looks nicer when you've got smaller numbers to start with. But it's not gonna give us an extra mark, put it that way, yeah. The only chance that it might give us is if I messed up here and put a +1 instead of the -1, then I would lose the mark.
Yeah, not
So
worth it.
that's the only thing. But it looks nicer. It just shows
Yeah.
to whoever's marking you that I can factorize too. In here, actually E is easier than D because you only need to get rid of the X by timing by X the top. And do the same at the bottom. We'll get rid of the fraction where you've got an X there. X plus 2 over X. So X times 3X, 3X squared. Need to watch that. It's not 4X. X times 1 over X is X times X divided by X, which is just
1.
1. There you go. We got rid of that fraction. X times X, X squared.
X squared.
Good. Plus 1.
And then plus 1. Oh, plus
No,
2.
because it's
2.
2 over X,
Yeah.
isn't it?
I was just checking, Kirsty, you were awake there, just in
2.
case you were.
Don't worry.
2X divided by X is 2 times 1, which is 2. And that's
Trust
us.
me, it's working now.
We can't do anything with that one.
Yep.
And for this one, we're going to multiply both top and bottom with the denominator here.
I really don't like these, but I guess I need to learn them.
Yeah, it's just trying
Anybody
to.
likes these.
Yeah, no.
True.
Algebraic fraction is probably one of the most hated topic.
Yeah.
Because
Well,
yeah, it makes you, to be honest, I don't mind it too much because I'm always surprised with, oh, this has got this or that, but that's maybe me. So 4x squared, yeah, this is where I like it because it becomes 4x squared minus 1. And straight away, my head is telling me, oh, I've got a difference of 2 squares. Yeah?
yes.
Because I've got a difference of 2 squares, I am not going to expand the one at the bottom. Because what if the top now can simplify with the bottom? I'm going to do extra work that is not needed. And any extra work tends to send you into an extra way of making a mistake. So now I can see 2x plus 1 times 2x minus 1 because it's difference of 2 squares.
2x minus 2 plus 1.
Or 2x minus 1 times 2x plus 1. The problem is if I had started to expand the bottom, I might not have noticed that I could have simplified it. Do you see? That's probably why it's wiser to just look what you've got and think, oh, maybe there is a way to simplify this. And that's us now. We've got a 2x plus 1,
2x
big
plus
group,
1,
2x plus 1. And now our final answer is just 2x minus 1 divided by 4. And that looks very complicated to start with, but in fact, it's just 2x minus 1 divided by 4.
That's what I mean. Sometimes I think I would look at that question and be like, questioning myself, how can that answer be so simple when the question initially looks more difficult? Like I would think to myself, oh, I've done something wrong.
So
Shouldn't be that simple.
I'll give you a tip. If I replace here x with 1, what do I get? 2 times 1?
Yeah.
2. 2 minus 1?
1.
1. 1 over 4 is a quarter. Now, check. 1 square is 1. 2 times 1 is 2 plus 1, 3. So you've got 3 here. So here we said 4 over 4 minus a quarter, which is 3 over 4, divided by 3. So 3 over 4, 3 quarters divided by 3 is just a quarter.
Yeah.
So now you've noticed straight away by using a number like 1, you've quickly checked that this is the right answer because you've just substituted a number inside and both are giving you the same answer.
Yeah.
Okay. And that's a quick way for you to be able to check that out. Okay. So yeah, it's tedious, but there is a way to check our answer, yeah. But algebraic fraction is something that we need to be able to do.
Yeah.
And because we've only got 10 minutes left, I'm not going to go through the next topic. We've done add and subtract fractions, and I think it was good to go through them and be comfortable with them. And if you can add and subtract fraction, it's much easier than multiplying or dividing fractions.
Yeah, I think it's just practice on these sort of things. Getting a bit more confident with.
Because you'd be surprised if I ask 2 students a quarter plus a quarter and a quarter of a quarter, they give me the answer for a quarter of a quarter much easier than they do when I ask them to add a quarter and a quarter.
Yeah.
Okay.
That's the thing. I think when I first come into the class, I'm a bit like, because I've not had been using my brain for maths, but the longer we go into it, the more I'm like, oh no, because obviously my brain's got used to it.
Okay. Okay, so next week I'll prepare this. I'll put a wee starter question, maybe with some percentages and stuff, just to to make us tick with percentages.
Okay.
And then we'll go through the multiplication and division. And I'll check. I think after that, After algebraic fractions, I think the next topic after that should be, so yeah, so we're probably going to
You said
start.
it's this week coming that you're having a meeting about at the college about what's going to happen with assessments. So
Yeah,
will
so
we know kind of this time next week then for the next class?
No, there should be. I think I'll find out. I'll let you know anyway.
Okay.
But
And
I
there
think
is going to be a class next week, is that right?
at the moment, yeah.
Yeah.
I've not been told not.
It's usually, I don't know if they have October break. That's the thing with colleges and uni. I don't think that actually happens,
I think because they start in September, but because we started in August, maybe we might get one. I'll speak to whoever.
Yeah, that's what I was
thinking. It's meant to be like a reading week or something like that, but.
Oh, wait, hold on. Sophie's just messaged. Did you see that, Kirsty?
Yeah, Sophie says my college is having an October week next week.
The whole
that
week?
Would apply to FE, would it not? All FE places. If they are having an October week, then that would.
Yeah, I'll check, but I'll let you know during the week anyway. Because after the multiplication division, we'll be looking at gradient.
Well, my work doesn't have one, so it doesn't bother me. I'll still be here.
Yeah, I'm self-isolating, so let's crack on. That's
Yeah, if we can get stuff, earlier than, if we can finish before I think because we're gonna do no exam this year, they're gonna try to push it right to the end before they give you. So the time we spend now is probably more time for you to revise or have a week off to revise before a full prelim. But again, we're gonna wait for SQA to tell us. So because SQA might be the one that are gonna send the prelims if they think it's not gonna be fair for the different schools coming with different prelims at different times. So if it's possible to do a prelim in schools, then the SQA should be able to give one.
It's a lot of work that goes into that, isn't there? So it's
I think it's going to be extra work because we used to have invigilated, we used to have markers done for us. So now the work is going to come onto us.
Yeah.
It is, yeah.
Because it's part of us being able to assess and not base it just on the prelim, base it on the whole year, which make it a bit of a fairer way to to give the final mark.
Yep.
Okay
then.
All right, so I think that's going to be us, and if I hear anything, I'll let you know, and I'll definitely find out for next week.
Okay, thanks very much.
Okay,
thank you.
Yeah, if you send us out your YouTube thing.
Yeah, the links. Once I've got the links,
I'll give you a good review.
I'll let you know.
I'll tell you.
You can give a thumbs up or.
I'll give you plenty of.
All right.
Depends what you give me. Depends how you mark my assessment.
Okay. Put it that way. I don't get any money from.
I don't get
YouTube,
commission.
so.